Hello, and welcome to this video on Introduction to Welding Symbols. To begin with, let me start by sharing the screen so you can follow along on the PowerPoint. My name is Girish Kelkar, and I am a welding consultant operating as WJM Technologies. Additional information about my consulting business is on the web at welding-consultant.com. In this video, we're going to review welding symbols, and for that, I have used two reference documents. One is AWS 2.4, standard welding symbols for welding, brazing, and non-destructive examination, and AWS 3.0, standard welding terms and definitions. For those who are new to welding, AWS is American Welding Society, and it is based in the United States and publishes many relevant welding documents, including these two. There are similar societies in other parts of the world, including in Europe, and the welding terminology and the symbols are slightly different. So you have to make sure that you are following the requirements of the local industry standards. There are videos on this welding YouTube channel, such as joints and welds in the weld design playlist and weld section analysis in the metallurgy playlist. These two would be very useful for you to review before you watch this video, so that you can get all the information that can be shared in this one. Other videos such as fillet weld measurements, bonds in resistance welding, and laser beam quality will also be useful. Welding symbol is a graphical representation providing information of the weld on the drawing. Now that information can include location and in terms of which side the weld is going to be made from, the type of weld, whether it's a fillet weld or a butt weld, so on, size and length of the weld, or any special information which can be in the tail of the weld. Keep in mind there can be a lot of information which is not on the welding symbol, and for that you have to look at the drawing notes, any welding specifications, and process documents and contract documents. In this video, we are going to review 4 commonly used weld types: the fillet weld in T-joints, groove weld in butt joints, spot welds in resistance welding and laser beam welding, and seam welds in resistance welding and laser beam welding. The basic requirement for a welding symbol is, again, this is according to AWS, that it has to have a horizontal line and a bent line attached to it with an arrow at the end. Now, the orientation can be any. It could be bent to the right or left or up or down. It doesn't matter. You cannot have just a horizontal line, and you also don't have one where the angle is 90 degrees. So it's always a horizontal line with a slightly bent line at an angle with an arrow at the tip. So that's the basic requirement for every welding symbol. Here we can look at a T-junction in schematic. So this is a T-junction. There are 2 welds have been made. And of course, this is a 2-dimensional section. And we have a welding symbol where the arrow is pointing to one of those welds. The arrow which is pointing to a certain weld, that is called the arrow side weld. And the information of the arrow side weld is below the horizontal line. The information on the other side weld is above the horizontal line. You can depict 2 welds in the same symbol as long as both welds are on the same weld interface. So here is the weld interface, and we have one fillet weld and the other fillet weld on either end of the same weld interface. Then those can be depicted on the same welding symbol. You could have another weld below over here on the same component, but that's not on the same welding interface. Then you cannot use the same welding symbol. Then if you have a weld below over here to another component, then you'll have to have an independent welding symbol. Let's see what the difference is between weld symbol and welding symbol. Here again, I'm showing a schematic of a T-joint with a fillet weld. And the fillet weld symbol is a triangle as shown. This is a 45-degree triangle with the vertical edge of the fillet as shown and the angle edge as shown over here. So this is a symbol for a fillet weld. The symbol for the fillet weld in combination with the horizontal line and the angle line combined becomes the welding symbol. Now, there are restrictions on this symbol for fillet weld. You cannot have the vertical line on the other side as shown over here. That is not acceptable. And no matter what the size of these individual legs in real life are, the triangle is always shown as having equal legs on either side. Here we depict a fillet weld in a T-junction. So we have two components as shown over here and a fillet weld as shown. The size of the fillet weld, the legs on either side are 3 units, and the length of the weld is 15 units. That will be depicted in the welding symbol as follows. We have the fillet weld symbol, which is shown. And to the left of the symbol is 3, that is the weld size. And to the right of the symbol is 15, that is the length of the weld. We also have a feature over here called the tail of the weld. So if you need additional information, you can put it in the tail of the weld. In this case, we are showing that the weld is going to be GMOP. That means the design engineer needs the weld to be made with the GMOP process. So in real life, on the part drawing, you need not have the length and the size of the welds if that information is already in the welding symbol. What you will still need on the part drawing is where exactly do we start this weld from or stop this weld. So that location information still has to be on the part drawing. That is not in the welding symbol. Also not in the welding symbol is direction of welding. Do we want to start on the left and end at the right, or start on the right and go back? Or if it's a long weld, do we do it in segments? All of that information is not in the welding symbol. That has to be in the process document. So there is some information on the welding symbol, but not all. Here's an example of a fillet weld with a fillet weld on both sides, arrow side and the other side. So the arrow side weld, as shown over here, has legs size the same. And that's why you need just one number, because both legs are the same size. The weld on the other side, in this case, is shown having legs of 2 different sizes, 3 and 5. So over here, we show 3 by 5 for the fillet weld dimensions. But which side is 3 and which side is 5, that is not shown in the welding symbol. That still has to be shown on the part drawing. We also do not show a length of the weld. So this space is empty over here. That would indicate that either this weld is expected to be the full length of the component, or the actual length is actually drawn or shown on the drawing. In this welding symbol, we also do not show the tail. Now, the tail is not a necessary component of the welding symbol. Tail is optional. So if there's no information to be shared in the tail, you don't have to show the tail in the weld on the welding symbol. A lot of the welds, especially long ones, are often made intermittent because you want to limit the amount of heat input to reduce the amount of distortion of the part. Here I'm showing a schematic of a component which has been made with 3 welds, 3 segments. Over here in the part in the welding symbol, we have 3 on the left. That is the size of the weld. So each leg on both sides is 3. On the right, now we have 2 numbers, 10-15. So 10 is the length of the individual segment, and 15 is the pitch. Pitch is the distance between the center points of the 2 adjacent welds. So 10 is the length, 15 is the pitch. And again, if this information is provided on the welding symbol, you do not need to provide it on the drawing. But what you still need to show, where do we start the sequence from, or where do we end? And also, the welding symbol does not show the direction of welding. It doesn't show whether we start on the left and weld to the right, or vice versa, or back step. All of that information, process information, has to be in a process document. Let's look at square groove welds. Here I'm showing you a 2D cross-section of a butt joint. So the two parts are butting against each other. And we can see that the weld has been made. It's a cross-section. So we have made the weld, taken a cross-section. Again, if you're not familiar with cross-sections, please review the previous videos that I have mentioned. Here I'm showing a weld which has gone down the groove, but it has not gone down full. It has only gone about 3 units into the interface. Also, the surface of the weld is flat. So we are not seeing the crown, which we typically would see in a weld like this. So this is a partial joint penetration weld because it is not going down 100% through the thickness of that component. So here we say partial joint penetration of unit 3. So that 3 is to the left of this symbol. Now this is a symbol for square groove joint design. So square groove joint is depicted as 2 parallel lines, vertical parallel lines. The number 3 is the minimum depth required. So the depth can be more than 3, but not less. In the square groove symbol, on top of that, we also see a horizontal line. That horizontal line indicates that the weld crown has to be ground flush. That means whatever the crown material is, that has to be removed. And in this particular case, the design engineer is recommending that that be done, or requiring that be done by grinding. So that is the G stands for grinding. There could be other choices for that. We can do that by chipping or machining or many other types, whatever material removal techniques you want to use, but that has to be specified over here. Over here, I'm showing the length of the weld as 15. Since this is a 2D cross-section, we cannot see the length, but 15 would be the length of this weld. Again, the start and stop points are not specified. That would be on the part drawing. In the tail of the weld, we see GTAW. GTAW means gas tungsten arc welding. So the design engineer is requiring that this weld be made with gas tungsten arc welding. Another variant of groove welding is CJP, is complete joint penetration, CJP. That means the entire thickness of the weld has been fused together. Over here, we can see a cross-section of such a weld. We can see the crown, we can see the root, because now the weld has extended beyond the bottom surface, so that is called the root. Again, for details of all this, look at the previous video on joints and welds. And we are having a welding symbol over here. We have the horizontal line, the angle line, and now we are showing by dotted line where the original weld surface was. So this is a V shape over here. So this is a V groove weld. The V groove weld is depicted by 2 lines at a 90-degree angle, irrespective of the actual angle. The actual angle could be different. If the actual angle is 30 degrees, you can say that over here. It can be 45, it could be 60 degrees, but the symbol itself is always at 90 degrees. This is the arrow side. That's where the energy came in. So that's why that is the arrow side. And the other side is where the root dropped out. And it didn't drop out, but the root extended into the other side. And that's why the other side information is above the horizontal line. So here we are saying that we have to have the root, but the root can extend a maximum 1.5 units from the back surface. So that is a requirement. Over here, we are not showing either the size of the weld or the length of the weld. So we're not showing the size of the weld, which essentially implies it is a CJP weld. That means full joint, complete joint penetration. We still see that information in the tail. So the design engineer has chosen to reinforce that information that it is a CJP, but that information is a little bit redundant. We also don't see the length of the weld. That could imply that the entire length of the component has to be welded, or the length could be on the part drawing. So that has to be confirmed. In addition to fillet welds and groove welds, one of the common welds is spot welding. Spot welding, in this case, I'm showing a laser spot weld. in that welding symbol. Now, how do you know it's a laser spot weld? It is because we have that specified in the tail, LBW. That means laser beam welding. Most welding processes have an acronym, a 3 or 4 letter acronym. So in this case, it is LBW, laser beam welding. We are pointing to the surface. This is the arrow side, and we are showing a laser beam coming down from the vertical. And so the information from the arrow side has to be below the horizontal line. So we are showing the spot weld as a circle. And the laser is coming down from the top. So that is the arrow side. So the circle is below the horizontal line. To the left is the spot diameter. So that diameter is the diameter of the weld at the weld interface, not on the surface. This is the diameter of the weld at the weld interface, and that is 10 units. This symbol would not change much if there was other techniques were used, such as say TIG welding or plasma or electron beam. All you have to do is change the description in the tail of the weld. You can use lasers for seam welding. So seam welding is a continuous weld over a length of that component, where the weld, seam welding, the terminology is typically used when you have a lap weld and you're going down all the way to the welding interface. So the previous two welds, which we also reviewed, such as the fillet weld and groove weld, they are also technically speaking seam welds because they are extending over a length of the time. They are not spot welds, but they're not called seam welds. But when you have lap welds and the energy goes down all the way to the weld interface, they are referred to as seam welds. So here I'm showing you a laser lap seam weld. So we have a component over here, the weld was made. And if you would have taken a cross section, again, this is all schematic. If you would have taken a cross section, you would see the weld energy go down to the interface, and the width of the weld at the interface would be 5. Over here, we are taking a longitudinal section along the length of the weld, and the width at the length of the weld along the interface would be 30. So those two numbers are depicted in the welding symbol, 5 to the left of the welding symbol and 30 to the right. In this case, the welding symbol looks a little bit different than a spot weld. Spot weld was a circle. A seam weld is a circle with 2 horizontal lines in the middle. So that's a seam weld symbol. Now, this symbol does not have a tail and does not say LBW. So how do we know this is supposed to be a laser weld? So for that, you will have to look at the part drawing. So oftentimes what happens is you might have an assembly drawing with multiple seam welds. And if all of them are made with a laser, so instead of showing each symbol with a tail and saying LBW, the information might be just in the notes in a single line saying that all seam welds are made with laser welding. So that is why sometimes you don't see that process information in the tail of the weld. Here again, we could have made the same weld with TIG welding, depending on the thickness of the components, or electron beam welding, and maybe plasma welding. Resistance spot welding is unique in that, again, here I'm showing you a cross-section. 2 parts were welded with a resistance weld, and there's a nugget in the middle, and the diameter of the nugget at the interface is 10. Uniqueness about spot resistance welding is that the energy comes from both sides. So you have 2 electrodes coming from both sides. So there is no real arrow side or the other side. So that is why the resistance spot welding symbol is actually right on the line. So half of that circle is above the line, half is below the line. So when you see that circle, which is half up and half below, you typically know that this is a resistance welding spot. The diameter of the spot is 10. And we have additional information in the tail, which says the design engineer requires you to use tungsten electrodes. So that is a specification provided. With resistance welding also, we can make seam welds. That is also a common process. Sorry, before we go there, let's look at assemblies with resistance spot welding. This is also quite common. There are many assemblies with resistance spot welding where 2 sheet metal parts are put together and combined with multiple spots of the order of 20 to 50 is not uncommon. In that case, we have additional information in the spot welding symbol. We have the resistance spot weld symbol itself, the circle right on the horizontal line. We have a number on the left, that is a spot diameter, which is shown in the cross section over here, and a number on the right, which is now the spot spacing. This is not the length of the weld, but this is the spacing between the two spots. So in spot weld, this number is the spacing. And there's a number below over here, 3, which is the number of spots. So we have spot diameter of 5, spacing of 15, and number of spots of 3. But we still don't know exactly where to make these welds on that drawing. So that information, again, has to be on the part drawing. And the spot on the left is shown at 6 units from the left margin and left surface, and 12 units from the on the horizontal surface on the top. Again, we still don't know whether these have to be made in sequence or what sequence and so on. Again, that information has to be in the process document that you won't find in the welding symbol. Resistance welding can also be used to make seam welds. Again, seam welds is a process where you are making a lap weld and the energy is going down all the way to the interface. Again, with resistance welding, we usually have 2 electrodes on both sides, so there is no arrow side or opposite side. That's why the welding symbol is right on the line. And again, where we have the size of the weld as 5, the length of the weld as 30, and we can write 5 on the left and 30 on the right. And this is a seam welding symbol. This is specifically for resistance welding because that's how the process works, because we have energy coming from both sides. It's not directional. So in this document, we have reviewed 4 of the most commonly used welding symbols and types. So we looked at fillet welds in T-joints. Now, it doesn't have to be a T-joint. It can be a lap joint. The welding symbol doesn't change that much. Groove weld in butt joints. Now, the grooves I have shown were square and V groove, but there could be many options. You could have J groove or U groove or bevel. Again, but that just changes the symbol of the groove, but overall welding symbol doesn't change much. We also looked at special situations in butt welds, where in one case, we saw that the top of the crown was machined off. And in one case, we saw that there was a requirement for the root drop. So those are special requirements, which are quite common in butt welding. We also reviewed spot welds for resistance welding and laser beam welding. We also reviewed seam welds for resistance welding and laser beam welding. Again, there's nothing magic about these. Spot and seam welds can be made with TIG welding, plasma, even electron beam welding. So with minor variations, you can use those symbols for many processes. So these 4, what we have reviewed, would probably constitute majority of the welds that you will make. Keep in mind that the welding symbol provides information for size, shape, length, and type of weld, whether it's a fillet weld or a groove weld and so on, and also any special requirements for the profile of the weld. But still, there's a lot of information which is not there in the terms of location of the weld on the part, length of the weld, sequence of welding, types of the filler wire which you're supposed to use, or shielding gases. All of that information has to be in a process document. So in addition to the welding symbol, you need a lot of other documentation to truly understand how the design engineer expects you to make this weld. If in doubt, always contact the design engineer for clarification, because you're going to spend a lot of time and effort trying to make this weld, and you don't want to make something which at the end does not meet the expectations. I want to thank you for your time in reviewing this video. If you're interested in learning more about welding and joining, please subscribe to this YouTube channel by clicking on the subscribe button, not this button over here, but below your screen, there'll be a similar button, and please click on that. There are a lot of videos and other playlists on this channel, including those for arc welding, resistance welding, laser welding, welding design, and metallurgy. So there's a lot of learning to do. I want to thank you for your time again, and I want to wish you the best in your endeavors to improve weld quality. Take care.